So legend has it, you have methane and iodide, two stable molecules, so they have no reason to get together. So it takes a lot of energy to push them together. But once they do, it happens through a radical swap where one hydrogen is exchanged for one iodide. Now, once they get together, they're called methyl iodide. They're married, they're nice and happy, nice tetrahedral, balanced and stable. But as soon as they hit troubled waters, and I mean literally because it requires a polar solvent for this drama to happen in, iodide, being more electronegative than carbon, will just leave to go hang out in the solvent. But he doesn't just leave, he leave and take all the money in the account, all the electrons. So he leaves with a negative charge electron rich, leaving carbon with a positive charge electron poor, because remember, she started off with 4 hydrogen, swapped it for an iodide, and now he left, leaving her with CH3 and a plus charge. Not only is she electron poor, she is now flat and plain or crushed. She is heartbroken with a hole in her heart because she's an empty p orbital. And because she's reactive, she will just take on the first decent nucleophile that comes along. That is the story anyways, believe it or not. And because when iodine left, it left with all the electrons, we call that a heterolytic cleavage. And remember that because no two girls respond to heartbreak the same way, the same thing goes for different carbocation. A tertiary carbocation is going to react differently than a primary or a secondary carbocation.